All right, y'all. This is a little practice using the definition of the derivative that we came up with today. So here it says let f of x equal x squared plus 5x, and we're being asked to find f prime of x and f prime of 3. Just a reminder that this notation here denotes the derivative. So to begin, we will write down the definition of the derivative. The derivative is the limit as h approaches 0 of the slope of the secant line. All right. So now we're going to actually use the function rule. So wherever we see an x, we're going to put an x plus h. And now we are going to subtract off f of x. Maybe I'll put this down here. Now we're subtracting off f of x. I'm going to keep making this error, and so I hope you can remind me in class. We need to include this limit statement until the very end where we substitute h equals 0. Okay. So from here to here, we have just substituted what we know about the function rule. Now we're going to do some algebra, just to simplify the expression that we're looking at. So this first chunk, x squared plus 2hx, don't forget the 2, plus 5x plus 5h minus x squared minus 5x. While we're at it, maybe it'll help to just have another justification for why this is a squared plus 2ab plus b squared. Here is a plus b. Here's another a plus b. We're going to square it. So we have a plus b times a plus b. So here we have a squared. In the bottom we have b times b, which is b squared. Here we have ab, and there we have another. So there is my 2 copies of ab. And we're dividing by h. So now at this step, we have to have absolute confidence that we can simplify this down to cancel stuff and factor out an h. We have to have confidence. It's possible every time. So x squared and x squared will cancel. 5x and negative 5x will cancel. Then we must be left with a bunch of stuff that has h in it so we can factor it out. So we have 2hx plus h squared plus 5h with an h on the bottom. We factor that h out to cancel with the h on the bottom, and we're left with 2x plus h plus 5. These h's, of course, will cancel. That was the whole point of this. That was the whole goal. So we have the limit as h approaches 0 of 2x plus h plus 5. And now we confidently don't write it down because we are now substituting h equals 0. So we have 2x plus 0 plus 5. And at the end of the day, we get 2x plus 5. And this is the derivative of the function. We were asked to find f prime, and now f prime of 3. The derivative is a function, so we are able to plug in different x values and get the derivative at a specific point, right? Because the tangent line is going to be different based off where in the graph you are.